So in this, we are going to look at first order differential equations. These are variable separation problems. By the way, full screen mode on YouTube is best for these. So the first one, dy dx equals 3x squared times y. So in this one, what we're going to do, so let's go here. Hang on a second. The default setting for this pen is actually quite large. Okay, dy over dx equals 3x squared. 3x squared, let's just start that again, 3x squared y. Okay, so what we're going to do is multiply both sides by dx. Okay, and divide both sides by y. So there we have it. That was easy. So let's just write that out again. 1 over y dy equals, we're just putting in the integrals as well, 3x squared dx. Okay, so that is the log of the absolute value of y equals 3x squared. The integral of that is 3 times x cubed over 3, and that is simply x cubed. And finally, we put in the coefficient, the undetermined coefficient there. So that's the first one there. Let's move on to the second one. dy dx equals this one here. So dy dx equals 2x, e to the 2x plus 3y. Okay. So I'll do this one in blue. Dy over dx equals e to the 2x plus 3y. Okay. Something to remember here, nota bene, is that e to the a plus b is equal to e times a, or e to the power of a times e to the power of b. So what we could do actually with this one is rewrite it as e to the 2x times e to the 3y. Okay, and now what we could do is just rearrange the equation. So, for example, we can divide both sides by e to 3y. So, or what we could do here is just rewrite the equation essentially. Integral of, if we divide by e to the 3y, essentially we have multiplying by e to the minus 3y dy, and that is equal to the integral of e to the 2x dx. So, integrating both sides there, we would get e to the minus 3y over 3 equals e to the 2x over 2 plus c. Okay, and that is the answer to the second one. So that's the answer to the first one there, is up there, and this is the answer to the second one. This is the answer to the first one. And the last one is dx over dt equals e to the x cos t. This looks straightforward enough. Let's just do this one now in red. Dx over dt equals e to the x cos t. Okay, so again, integral of e to the minus x dx equals the integral of cos t dt. And so there we would have the integral of e to the minus x is minus e to the minus x, and that is equal to sine of t plus c. Okay. Okay, so you could come up with little simplifications of a couple of those, but really we've done the job. Okay, so let's just go back over it again. You solve the first order variable separable ODEs, and there we have it there. So a couple of key things: basic, being able to handle basic calculations like that, or exponentials, and also, for example, 1 over e to the a is also equal to e to the minus a. We done that a few times in these calculations, so it just might help to have a quick reminder about that. So, two more. Find y as an explicit function of x when we have boundary conditions. These are two more, except all we are doing is adding in boundary conditions so we can find plus c. So, dy we'll divide both sides by 1 over y squared. and multiply both sides by x squared, or dx. Okay, so that's what we have there to go on so far. That's just rewriting that equation. And so we have y to the minus 2 times the integral of y to the minus 2 dy is equal to the integral of x to the minus 2 dx. So working out that both sides, that's just the simple power integration rule. That is minus 1 over y equals minus 1 over x plus c, and y at x equal to 2, y is equal to 1. That's just another way of writing that. So minus 1 is equal to minus 1 over 2. Minus 1 over 1 is just minus 1, equals minus a half plus c. Necessarily, c is equal to minus a half. Okay, and so therefore what we have here is minus 1 over y equals minus 1 over x minus a half. That's okay, but what we do is actually we could do so much more with that. First off, what we could do there is cross multiply the right hand side. So minus 1 over y is equal to minus 2 minus x over 2x. Okay, and we can get rid of the minus signs, so we have 1 over y equals 2 plus x over 2x, and therefore y is equal to, just invert above and below, 2x over 2 plus x. That's a nice tidy answer there. So again, it is y is equal to 2x over 2 plus x. Okay, let's look at the second one here. We don't really have much room. See if I can clone this page. Yep, there we go. Sorry, just check out that clone. Yeah, it's good, yeah. So, make a bit of room here. This is the page that's been cloned. So, dy over dx equals 2 times the square root of y over x. Okay, so let's just rewrite that. I'm going to get straight into this one. Dy over 2 root y is equal to dx over x. Okay, so integral of 2 times y to the power of minus a half dy is equal to integral of x to the minus 1 dx. Integral of x is straightforward enough. That is log of x. 2 times y to the minus a half, that will work out to be y to the 1 half, or square root of y, and that is equal to ln, the natural log of x, plus c. Okay, happy days. So now, at x equal to 1, y is equal to 4. Okay, and so therefore, square root of 4 is 2, and that's equal to the natural log of 1 plus c. Okay, a natural log of 1, bit of calculator work, is, let's just check. Oops. It's 0. I've a sort of habit of doing these things and then realizing I made a slight error. So that's why I just wanted to double check on my calculator, not rely on a faulty memory. So the natural log of 1 is 0. So c is equal to 2. Okay, that's from the old one. So what we have here is square root of y is equal to natural log of x plus 2. What we could do there is square both sides. Y is equal to natural log of x plus 2 squared. And that's the job done. That's the second one done. So those are variable separable ODEs. There's my recorder.